small pieces, bottom way stupid. Melts at 715, aluminum. I don't care if it's that thin or that thick, basically melts at 1172. That means you got 450 degrees to play with. That's what's so great, not 30-35. Take a brass or stainless steel brush, knock that oxidation. Do not, and I'll tell you, do not use steel or steel wool. Steel is a ferrous metal that contaminates aluminum. Heat it up. I'm using propane, acetylene oxygen, whatever, don't care. I want you to think solid. Heat the base metal, not the rods. All we're going to do is bring that base metal up to 715. How do we know that? Aluminum does not change color. The rod tells us. Use the rod as a temp stick. Now you drag it, nothing's happening. Get out. I go around like a big old Ferris wheel. Drag it, get out. Get in a habit of doing that. You know, when you examine it like that, don't do that. You preheat the rod, you're going to go from the back. Make the base metal melt the rod, not the wood. Think solder, keep it simple because it is. Drag it, get out. There you go, sir. There it is. Rod's going good. Pull the heat. Keep the rod going and work that on in. Need more heat. Heat back, heat on, heat off, all the way down the line. That is soldering. Now, turn that into a brazing rod, I'll bring the heat back. It's going to get smooth and shiny. I want y'all to look for a haze, a cloudiness, and guide you through it. Okay, smooth and shiny. Here comes that haze. Here comes the cloudiness. Get out, we're done, that's it, no more. Now the rod told us two things. Number one, if I left the heat much longer, yes, I've lost it, base metal and all. Second thing the rod told me, the pores opened up and those alloys bond. So we went from soldering, which sits on top, don't have much strength, to brazing, which becomes part of it. 2 steps. Keep it simple because it is. True way to show you is with an x-ray machine. Since I don't have them, file that down to show it to you. Matter of fact, get that file down. I'm going to put a cross cut in there. Exactly what I'm trying to tell you, and that's close enough. Part of it. Now, because of this happening, I go into the real times. Air conditioners, refrigeration lights on the high pressure side, it's not going to blow it off because it's part of it. Same rod does pot metal, pewter, white metal. When you do pot metal, pewter, white metal, do not go back to the cloudiness. Melting point's too low. Just do the first step. You automatically get the bond. Now, you want to do pot metal, pewter, white metal, make it pretty easy. Go to a welding supply store and get what they call stop heat. Y'all familiar with that? It's like a Play-Doh putty. It's a heat sink. Pack it on everything. What you're going to do, absorbs the excess heat, makes popping pretty easy. Here's what I like to show welders. Die-cast aluminum like a motorcycle. Had a big old hump on it. I took the file, I beat it off. Brought that heat in there, started to smoke, pull the heat. 4, 5, 6, 7, 8 times. Same way a scoop shovel, bolts, motorcycle parts. Anything that has oil, burn it out. After it's done smoking, take your brush, clean it. Then I tinned it. Tinning means putting a thin layer. Smooth, shank it, cloudiness. Got the bond. All I did was I took a light piece of steel for the back. Literally built the rod on the steel, work it into what I tinned. After it cools, unclamp it, don't stick to steel. Nice and smooth, very little filing where you go. Hypothetically, if your thread's in there, take your brush, clean it. Now, put a steel bolt in there. Braze over the top. After it cools off, back out the steel bolt. That's it, got your threads. But